Welcome back to Business Mathematics 2 MA1203. I am Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So for today, we are going to discuss about linear programming problem, an algebraic approach. Remember, in the last session, we have talked about linear programming, but it just have two variable. And I can draw it in the plane, and I can find the corners if I use the method of corner to find the solution. So what about if I have n variable with n is greater than 2? Can I still solve the linear programming problem? So this one is the answer for it, that is called an algebraic approach, or we will call Simplex method. So the first one, we will talk about the standard maximization problem in the linear programming problem for n variable. That is, n can be greater than 2. So we would like to recall first what about the method of corner. So if I have this linear programming problem, so what do I have to do? I have to draw the domain that satisfy all the constraints, that what we usually call the feasible set. I can identify all the corners, and I put all the points into the profit, and the maximum one give you the maximum P, the minimum one give you the minimum P. Okay, that's what we usually call the method of corner. And you can have some other result if you have two adjacent points that have the same profit, and you can have also non-existent solution, no optimal solution, and so on. You have already learned that at the last session. So I would like to generalize this into a three-dimensional setting in three variable problem. Okay, so the first of all, I would like to start with this. Can I increase X such that the profit increase? Yes, I can increase X such that it gives you 4. Okay, this is the idea of a simplex method. That is a standard maximization, the method for linear programming in n dimension, n variable. So if I have achieve the higher X, can I increase the Y? Yes, I can increase the Y here, so I can get the maximum, the optimized solution. So that is the idea for this simplex method. So let's have a look. The first one we would like to discuss about what we usually call the standard maximization problem. In standard maximization problem, we assume that objective function is to be maximized. So I want to find the maximum. Objective function should be a maximum. If minimum, that is not a standard maximization problem. So all the variable involved should be non-negative. What is the variable involved here? P, X, Y, all should be non-negative. What do you mean by non-negative? It should be positive or 0. And all other linear constraints may be written, all the constraints may be written besides this, involving the variable is less than or equal to a non-negative constant. Don't forget, non-negative can be 0 or can be positive. Okay, so all of this is less than or equal to something that is non-negative, except this one. All the variables should be non-negative. X should be non-negative and Y should be non-negative. Okay, so this is what we usually call the standard maximization problem. So for this course, we would like to discuss what is the standard maximization problem and how to solve this, how to solve the standard maximization problem. Let's look at this problem. The first one, you add select variable, u, v, the select variable. So if you have the constraint is 2, except the X should be non-negative and Y should be non-negative. So you have two constraints, And these two constraints, you have to add slack variable, that is variable that have positive value, such that it will become an equality. Why? Because in the last session, we talked about how to find a solution of equality. How to find a set of linear equation, a system of linear equation. Yes, we can. But if we still have the less than or equal inequality, we cannot do anything about that. Okay, so first of all, we add slack variable. So the constraint that is not x greater than x is should be non-negative and y should be non-negative. The constraint this should be equal, inequality, and you add the profit, the objective function, the profit here to be maximized, but all of your terms should be on the left hand side. From this, you make what we usually call the simplex tableau. The simplex tableau. So the column that correspond to the column in identity matrix 1 0 0 0 1 0 0 0 1. So this is what we usually call basic variable. So u, v, and p is basic variable, and the other x, y is a non-basic variable. Okay, and this is the column of constant. And then express the basic variable in non-basic variable. So u equals in non-basic variable 12 minus 2x minus 3y. So you have this, v is this, p is this. Don't forget u, v, p, x, y should be non-negative, Find the basic solution. So we first start with the basic solution, that is x equals 0, y is equals 0. You remember the corner, the left corner, 0, 0. You start with 0, 0, x equals 0 and y equals 0. And we obtain x 0, y 0, u equals 12 this here because x is 0, y equals 0. You can substitute here. U equals 12, v equals 8, and p equals 0. So it corresponds, this point corresponds to the zero profit. The question is, can I increase x or y such that I have an increase in profit? And the answer is yes. Because x positive, if I increase x to a positive number, it will increase the profit. And if I increase y, don't forget y is non-negative. If I increase y, you will have an increase in profit. But what do you mean by increase of x? So from 0 you increase. From 0 you increase. So it will give you an increase in profit. Previously you have the profit is 0. Yeah? You want to increase this 0 profit. Okay, then increase the most influenceable, the most influential variable. So which one give you the most influential variable? X or Y? X. Because if you have X and Y is the same, which one give you the more profit? The X. So I will choose, I want to increase X rather than Y. The first one I would like to increase is X rather than Y. The first one, yeah. So Y, I remain fixed 0, y should be fixed 0, and I want to increase x. So how can I increase x? What is the maximum of x that I can choose? So if I substitute y equals 0, you have u equals 12 minus 2x, and v is 8 minus 2x. Okay, don't forget x, u and v should be greater than or equal to 0. X and y should be greater than or equal to 0. So you have this one. X is greater than or equal to 0, and x should be greater than or equal to 0. Okay, but don't forget u is greater than or equal to 0. U is greater than or equal to 0. That will give you x should be less than or equal to 6. So x should be non-negative and less than 6 from the first equation. Okay, how do you get 6? 12 divided by 2. 12 divided by 2. What about the second one? V should be non-negative, so V should be greater than or equal to 0. And you can do algebraic, and you have x should be less than or equal to 4. How do you get 4? 8 divided by 2. So x should be 0 between 0 and 6 or 0 and 4. Which one will you take? 6 or 4? 6, isn't it? Yes, but remember, if you choose the maximum x should be 6, look at if you substitute 6 into the second equation. 2 times 6, 12. 8 minus 12 is minus 4. Uh-oh, you're in trouble because phi should be non-negative. Phi cannot be negative. So you have to choose the smallest ratio. So you have 8 divided by 2, 12 divided by 2. You have to choose the smallest one. That is 4. If you choose the largest one, one of the variable will give you a negative value, and we do not want that. So we have to choose x equals 4. So here, don't forget y is 0, x is 4, u is 4, v is 0, and p is 12. P is 12. How do you get u equals 4? Yeah, you can just substitute, yeah. u 12 minus 2x, x is 4. 12 minus 8 is 4. V, you substitute here x equals 4. 8 minus 8, 0. Okay, and the profit is 3x plus 2y. 3 times 4 plus 2 times 0 is 12. Okay, so this step I can summarize as this. At the simplex tableau, first of all, you want to find the most influential variable. I want to find what we usually call the pivot row. So the pivot row is have to be choose x the x column, because this is the most influential variable to the profit, the most negative one. Okay, so you choose this as your pivot column, and you can choose which row you want to choose. 12 divided by 2 here, or 8 divided by 2, 4. So you have to choose the smallest ratio. So you have to choose this as your pivot element. You have to choose this as your pivot element. So you have to bring this into 1. So you have 1 here, and then you have 4, and then so you have x equals 4. This one. But you have to change this into identity. You have to change this into the basic variable. Because the non-basic, if I read this, is 0. So you have to change this into your basic variable. So this should be 0, this should be 0, and you can use 2 times elementary row operation, and you get this. So you read this simplex tableau. X equals 4, u equals 4, x equals 4, u equals 4, p is 12. The rest is 0. Y is 0, v is 0. That's how you read this simplex tableau. Okay, yeah? This is pivot column, the most influential to the profit. The pivot row, the smallest ratio, and you make this into the column of identity matrix. You bring this into 1, all the other is 0, and you have this one. Okay, yeah? Okay. The question is, can I still increase the profit if I increase y? And the answer is yes. Why? Because if I move y here into the right hand side, p is a half y. P is a half y. Then if I increase y, that is non-negative, you will increase the profit. So I can still increase the profit by using the same technique to the variable y. Let's see. So I have to choose now, this is as my pivot column, because there are no other variable, just x and y. So I would like to choose the pivot row. Which one is the greatest? 4 divided by 2 or 4 divided by a half? Of course, the smallest ratio is 2. So I can choose this as my pivot element. I want to make this as 1, the other is 0. So you have in the end is this. So how do you read this? X equals 3, Y equals 2, profit is 13, and the other I don't care if this is 0. U equals 0 and phi equals 0. Okay, you just read the basic variable. The non-basic variable will be 0. Okay, so the maximum profit is 13 when x equals 3 and y equals 2 here. Okay, what about, we summarize the simplex method as follows. We add select variable to the problem, to the constraint. Okay, the specific constraint, the constraint that is not x is non-negative and y is non-negative. Not that. The constraint, the real constraint. Okay, this is the real constraint. 12 and 8, and I add the objective function. I make the simplex tableau. Don't forget, this is basic variable, non-basic variable, and the column. So I have to choose the most influential variable, the most influential non-basic variable. Influential, I mean influential to the profit. And I have to find the most negative. The most negative is x. So I can choose this. I have to choose the pivot element. So I have to choose which column do I have to become the pivot element. I choose the pivot element, the smallest ratio. The smallest ratio is this. I change this into 1 using elementary row operation, and the other will be 0. And you read. If it needed, if the y maybe have negative, you can do the same game in the third step. Okay, yeah? Let's look at the three-dimensional problem. Let's look at the three-dimensional problem. I want to maximize the profit. 2x plus 2y equals 0 with the constraint is this, and additional non-negative of the variable, non-negative variable. Okay, yeah, the real constraint with the non-negative variable. So the first of all, I add select variable because you have 3 inequality. That is not this one. Okay, 3 inequality. You add 3 select variable u, v, w. Okay, and the profit function you put it on the last row. Okay, and all the right hand side you should bring it to the left hand side. So you have this, make a simplex tableau, and then you have minus 2, minus 2, minus 1. So the most influential can be minus 2 or minus 2. You can use either x or y. This here I want to choose x. So you have to choose the pivot element. So you have choose the pivot column. What does the pivot row? You check the ratio. 7, 13, 28. So the smallest is the first row. So you have to choose this as your pivot element. You bring this into 1, and the other you have to bring this into 0 by using the elementary row operation. Okay, yeah? And then, this still have negative. So in the profit, if you change this into the right hand side, it will give you 1y. And y is non-negative. So if you increase the profit, you will, if you increase the y, so you increase the profit. So you can still do the same game. Here, you have choose the pivot column. You have to choose the pivot element, the pivot row, this one, or this one. And you know 7 divided by half is 14, 4, and this is 21 divided by 3 over 2 is 14. So the smallest ratio is this one. So I choose this as my pivot element, bring this into 1, and bring other into 0. So you can read this, x equals 5, y equals 4, z, because this is a non-basic variable, z equals 0, and the profit will give you 18. What about this one? X is 7, y non-basic variable 0, Z, non-basic variable 0, and the profit is 14. So x1, y0, z0 will give a profit of 14. And you increase this. Can I increase more? And the answer is no. Why? Because you have 2/3 z. If you bring this into the right hand side, p equals minus 2/3 z, because z is non-negative. So if you increase z, the profit will decrease. So this is your optimal solution. X equals 5, y equals 4, z equals 0, and your profit is 18. Okay, yeah? Okay, next is the standard minimization problem. We would not like to talk about this, but in short, we would like to look at problem that is minimizing of something, minimizing a cost of something. And what we usually call the standard minimization problem. But we will not discuss about this. Okay, that's all. Thank you.